Okay, so we'll look at the questions for this paper, May, June 2021, paper 1.1 and 1.2. Okay, so the first question here is about the induction. Okay, so basically the induction here is to prove the divisibility. So usual stuff, okay, that we do for the induction here, that will be the first is we give that statement a name. So let's say we call it as a Pn here. Okay, we give it a name here. So it's like this statement or this expression is divisible by 15. And after that, what we have would be the first case, okay, when we have got like the positive integers n. So the first value of the n that we have here is n is equals to 1. So we are trying to substitute in what is the n is equals to 1 here so that we get like a 45. So the 45 here might not be so clear yet, okay, it is divisible by 15. So what we could do is we could show that it is really divisible by 15 by writing that as a factor, as a multiple of the 15. Okay, so it is clear that here it is divisible by 15. So here we can say that the P1 is true. Okay, and for the following steps, okay, is assume the PK. So assume PK is divisible by 15 for some k is greater or equals to 1. So always remember when we assume this, it is actually to use the word which is like a sum. Okay, k is greater or equals to 1 there. So and then the next thing is optional, but usually I'll try to do that, which is to let, okay, what we have for the expression here to be a multiple of the 15. Okay, but when you try to do this kind of the statement, right, you also have to make sure that you specify this thing clearly. So if you write that as something like a 15 times a c, right, so you need to indicate that the c is an integer. Okay, if not, if you don't define this one, the c could be just anything, so which doesn't mean that it is divisible by 15 already. Okay, so we must have the c here is an integer such that it is divisible by a 15 like that. So the work later on is to replace the k with all the k plus 1 inside the expression here. So 4k becomes 4k plus 4, and then the power here k becomes a k plus 1. So usually what we want to do is we just want to split, okay, the terms, I mean the powers there. So for this one, we can actually split that into like a 2 power 4 with the 2 power 4k. Another one here, we have got like the k plus 1 for the power. So we can split that into the power k and also the power 1 there. So with that, right, okay, we evaluate the 16, which is the 2 power 4, and then the 31 here, which we just take out one of it. So means like here we have got 16 of the 2 power 4k. So we just take out one of the 2 power 4k together with another 15 of it. And this one is the same thing here, the 31 of the 31 power k here. We take out one of the 31 power k, and the rest of it is a 30 of the 31 power k there. Okay, so with that, we try to obtain what we have actually assumed earlier. So this is what we have actually assumed earlier. So we know that it is actually a 15c. So once we replace that with the 15c already, so later it's very easy for us to prove. So we could factorize out the 15 and the rest of it, okay, would be the terms which looks like this. So from here, it is clear that we can divide this by a 15. Okay, so with that, okay, we can conclude the pk plus 1 is true, and therefore we can say the conclusion from that. Okay, it's quite typical stuff that we do for the divisibility here. Okay, so if you look at the next question here, that is, okay, use the standard result from the MF19 to find the sum 1 minus r squared in terms of m. This is some usual stuff that we have from there. Basically, is to just sub in all the formula. So sum of 1, okay, is n. When we sum from the r equals to 1 to n there, so sum of 1 there is an n. Other than that is sum of r and also sum of the r squared. Okay. For this case here, right, if you want to simplify the expression here, what we do is we usually factorize the common term. So there's only one common term here, which is like a n here. And also at the same time, we will usually try to factorize out the fractions there. So we have got like a 1 half and a 1 over 6 then. So the fractions that we could factorize out is a 1 over 6. Okay, so here we factorize on 1/6 is because remember we want to avoid to work with the fractions in the last expression that we have there. Okay, it's easier to work with the expressions which is without the fraction. Okay, so after that is nothing much, we just have to tidy up. So expand everything and tidy up, we are getting expression which is a quadratic. Okay, if this quadratic could be factorized, usually we will factorize it, but in this case, it can't, okay, be factorized. So we will just leave our answer in this form. Okay, so this is a 3 marks question. So as for the second part here is a showing question. Okay, so what we have in the showing question here is that, okay, first is to show that we have got the first fraction here, and hence use the method of differences to find these sum here. Usually what we have in the showing here is that, okay, because it's quite difficult for us to actually work from the left to the right hand side. Okay, so usually because this is a showing question and it is not really testing us about like they want us to they are testing us about like the partial fraction. Okay, so for the case like this, right, we don't need to really use the partial fraction to do that because it's a showing question. This result here is going to be used in the sum later. So usually it would be okay that we do from the right hand side to the left hand side. Okay, basically it's to combine the two fractions there in order for us to get the result. Okay, so the key point here is they are not really testing us for the partial fraction. If they want us to test for the partial fraction, they would have like hide all the I mean they would just give us all the constants there and ask us to find what are the constants. Okay, but this is not the case. They just wanted to show for us to apply it later. Okay, so we could show that from the right to the left hand side here. And for the sum here, okay, because it's already given for the result there, okay, so it's to use the term that is being we are asked to show. So usually for the question which is like this, right, we need to list out the terms, okay. The method of differences still means we have to cancel off the terms and things like that so that we can actually have the terms, okay, where we just sub in, okay, r equals to 1, r equals to 2, and so on. So of course, this one is not so clear yet. Okay, we have to show one more term to show how the terms cancel. So you can draw some dotted line nicely to actually cancel off the terms there, right? And then we will just look at, okay, these are the remaining terms, okay, for the result there. Okay, so that's the method of differences, which is also quite a typical type of the question there. So the last part, okay, so you can see the last part here is a deduced question. So deduce that what happened when the n approaches infinity. So you can see this infinity sign here. So you need to deduce the value here. Basically, if the question here is a 1 mark question and it's a deduced question, so usually they don't need us to carry out a lot of the steps. In fact, you can look at the space also. The space also only gives us like a 2 lines there. So they don't expect us to do a lot of the work from there. So how do we actually look at this situation here is that, okay, what happened is, if we actually have got the this expression here, so when n approaches infinity, so remember the trick for us to work on it is that it is not about substituting the infinity inside there. Okay, it is, okay, from here, we are getting an n plus 1 over, so n plus 1 squared plus 1 is like n squared plus 2n plus 2. So this is to divide, okay, the numerator and the denominator by the highest power of the n. So highest power of the n that we have here is like the n squared. So when we divide, we get 1 over n plus 1 over n squared, divided by this is 1 plus 2 over n plus 2 over n squared there. So when n approaches infinity, so all the reciprocal terms will become a 0. So basically, this one gives us just a 0 for the term here, okay? And then that is why we only have the minus half, which is remain when the n approaches infinity. Okay, that's how we actually look at it. So quite standard question as well for this one here. Okay, Next question. So we have got a quartic equation that has all these roots here, alpha, beta, gamma, and delta. So we need to find a quartic equation whose roots are the cubes of the alpha, beta, and so on, and state the value of the sum of cubes of the roots. So find the new equation which is having the new roots, okay, is to let the new variable to be equal to like one of the roots. So let's say we let the y to be alpha cube there. So from there we have got the alpha is equals to y to the power of 1 over 3. Okay, make alpha as a subject here such that we can substitute this alpha into the equation because the alpha here should satisfy the equation. Okay, so we substitute that in. Okay, so what happens is that we want to make it into another quartic equation. So we will at some point we will get like this. Okay, so we'll get y power 4 over 3 is a 2y plus 1. So what we need to do is just we need to cube both sides such that we are getting this equation here that we just have to expand the right hand side. Okay, so after we expand the right hand side, tidy up, this would be the equation that we obtain, okay, for the roots, which is like having like the roots of like the alpha cube, beta cube, and so on. So, and the next one is to state the value of the alpha cube, beta cube, gamma cube plus a delta cube. This is the sum of the cubes. So basically, when they say state the value, it should be something that is very easy for us to work with. So basically, that is how we have got this. Because in this equation, right, the roots are already in cubes. Okay, these are already in cubes. So therefore, that is to actually use like, this is actually the sum of the roots. It's a negative b over a. Okay, they are already in cubes, right? So we are just adding the cubes. So these are the sum of the roots based on this new equation here. That we just use the negative b over a for the result. So the value for this part here will be 8. Right? So the following part of the question, part B, is to find the value of the 1 over alpha cube and so on. Okay, plus 1 over beta cube. So this one, okay, we could look at the situation where, okay, we could combine them. Okay, we could actually combine them. So we can observe what happened in this case here is that you just need to treat all these, okay, cubes as the equation, as the new roots for the equation there. So everything should come from the new equation. Okay, so for this part of the value here, once we actually combine them, we will actually get like the denominator is the sum of the, the product of all the roots, which is coming from the new equation. Numerator is the sum of the product of any 3 roots which is coming from the new equation. So everything is related to the new equation there. Okay, so this is e over a. This is negative d over a. Okay, so the a here is a 1. So we just need to take what are the values there. So negative d over a and also the e over a. Okay, so when we actually divide, we can actually get this value here easily. So everything is related to our new equation already. Okay. So in the next part here, okay, find the value of like the sum of the 4th power of the roots there. Okay. So what we have for this, you can see this question is quite short. I mean, the solution should be something that is very easy. So it only has got 2 marks there. So when we want to work with the expression which is like this, right, usually we will use the Sn. Okay, so what happened in this case is that it would be easier if we try to make use of the original equation instead of the new equation. Because in the original equation here, it has got only this kind of the expressions there. Okay, so from there, if we use the original equation there, we get S4 minus 2S3 minus S0 is equals to 0, which we could find the S4 very easily. So the S4 is just depending on the S3 and also the S0. S0 is a 4 because we have got 4 roots here. The value of the S3 is what we have done in the part A there. Okay, in the part A, we already have that value, which is an 8. So this is why it allows us to find this value of the S4 very easily. Okay, so it's just depending on the 2 terms there. Okay. Right. So let's look at the next question. Okay. So this is a transformation question. So matrix M represents a sequence of the two transformation, okay, that is given by, okay, so a rotation 60-degree anti-clockwise about the origin, and then there's a one-way stretch in the x direction, which is having the scale factor of the d. So let's just find out what is the matrix for each of the transformation first. So for the first transformation is a rotation 60-degree anti-clockwise. So for the rotation matrix, right, it's easier if you just memorize the matrix, okay? So we don't need to derive it on the spot. So just plug in the angle, the theta there into the matrix so we can evaluate it, and this is what we get. And for the other one is a stretch in the x direction with a scale factor of the d. So this would be the matrix of it. Okay, for the stretches, it's very easy. You just need to consider the unit square. Okay, you just need to consider the unit square. And because we are stretching it in the x direction with a factor d, so the 1, 0 will actually goes to a d0. So the image of the 1, 0 would be the first column of our matrix here. So this would be, the first column is a D0. And then the second column is the image of the 0, 1. So the 0, 1 is actually unchanged at all. Okay, so this is for the 0, 1. Okay, the second column. So after that, okay, we want to find the matrix M. The matrix M here is, it was like two transformations, one after another. So remember when we have got the case like this, right? The transformation that we do first, okay, will come later in the multiplication. So this is to use the second transformation to multiply by the first transformation, okay? So in matrix, the multiplication, the order matters, okay? So with that, we get this matrix after we carry out the multiplication from that, okay? So with that, okay, we have got the part B here. So the unit square in the xy plane is transformed is by n onto a parallelogram of the area of the half d square unit square. So show that the d is equals to 2. Okay, so the idea here is from a unit square which is having the area of 1 unit square, it is being transformed by m, okay, to a parallelogram which is having the unit which is like a half d square unit square. So we need to make use of the determinant, okay? Because the determinant is a scale factor of the area. So we need to find out what is the determinant of the m. So we have already found out what is the m earlier, right? Here. So we need to find out what is the determinant of the m here. So it will be in terms of the d. But it would be very nice that we will have like a d there. Okay, this is the determinant of the m. So this is the scale factor, okay, of the area. So it means that the 1 unit square, okay, will be enlarged, okay, by these d times to get a unit which is like a half d square. Okay, so we use the 1 to multiply by the d, it will give us a half d square. Okay, this is how we work with the area there. So it means 1 times d, okay, is equals to half d squared. So we can actually solve the d there. So the d value is actually equals to a 2. But you have to indicate that, okay, we are not going to consider the value where the d is equals to 0. Because it is already mentioned that the d here is not a 0 in the beginning of the question. So we also need to like sort of like mention about it. Okay. So that's for the second part. Okay. The third part is, okay, find matrix n such that the mn is 1, 1, half, half. So we need to find the matrix n here. Okay, so what happened in this case is that we are going to find the matrix n here, which we have got the mn is equals to 1, 1, half, half. So we now want to find the matrix n, right? To find the matrix n here, it is to multiply the m inverse from the left-hand side. Okay, so you need to be careful of the order there. So when you multiply the m inverse from the left-hand side, Okay, so this would be the right hand side is an M inverse times the matrix 1, 1, half, half. So the M inverse cannot be at the other side there. Okay, because what we did was we multiply the M inverse from the left for both sides there. Sorry. Okay, from the both sides there. So you have to follow. So what is the result? Okay, that it gives us is that M inverse times the M here, it becomes an identity. Okay, and the N here is just we are using the M inverse to multiply by that matrix, which is 1, 1, half, half there. Okay, but before that, we need to find the M inverse. So since we already have the D value, so we sub the D value into the M. So with that, we can find the M inverse. So of course, this is an inverse of a 2 by 2 matrix. We should have know how to use the formula straight away. Okay, it's just use the formula straight away to find the M inverse here. So with the M inverse here, okay, then we will have to multiply with the 1, 1, half, half. So nothing much for us to do. And just expand everything, and finally this is the matrix that we are getting from there. Okay, so while you work with the multiplication here, right, you might have all the over 2's, so it might not look nice. Okay, so you could factorize a half out, so you can leave the 1 over 4 outside there, such that it actually looks neater. Okay, for the these matrix N here. Okay, so the next part of the question is asking about the invariant lines. So the invariant lines is through the origin, okay, the transformation in the xy plane represented by the Mn. So we are using the matrix Mn here to multiply by the point xy that we are trying to transform. So it should give us the images, which is the x prime, y prime there. So we carry out the multiplication, and we are getting two equations there, which is involving the x prime and also the y prime. So we need to relate them. Okay, we are trying to find the equation of the invariant line. So we are using the y prime is equals to mx prime. So here we don't need to consider the intercept, okay, the c. So we are using just the y prime is equals to mx prime. Okay, that we relate them together. So y prime is equals to mx prime. And at the same time, our y is also equals to an mx there. So we can sub in the y is equals to mx there. Okay, and then later on, it is just to tidy up. So we are getting all the terms that has an x, right? But the coefficient of it will be something that is like a quadratic. So now, because the x here is some point, so our concern is that, okay, we just want to look at the quadratic equation here that we could factorize. Okay, so with that, we are getting the gradients. So m is half and also the negative one. So remember when they ask for the equation of the invariant lines, we have to write, okay, the form, which is like the y is equals to mx for the lines here. Okay, this is some usual thing that we always do lah for the invariant line. Okay, nothing special from here. All right. Okay, let's look at the other questions. Okay, so this is a polar question. So, okay, we have got the curve C has this polar equation, so it's slightly different. We have got the equation here is R is equals to A cotangent 1 over 3 pi minus a theta, where A is a positive constant and the theta is just in between 0 to 1 over 6 pi. So it is given that the greatest distance of a point on C from the pole is 2 over 3. So sketch C and show that the A is equals to 2. Okay. How do we show that the A is equals to 2 here? So we will look at it later. But now let's focus on the sketching part. So what happened in this sketching part is that you can see the question, the idea or the logic of the question. It is, okay, they ask us to sketch C first, then only they ask us to find the A. Okay, if it is expected for us to find the A first, they would have already set the question as like show that A equals to 2 and sketch C. So there is actually a logic behind that. So it's to sketch the C here first. So, I mean, if you want to look at the idea here, right? If we are looking at this is a cotangent graph, so usually, okay, in the question of a polar, if they ask us to sketch the to sketch the graph first, the graph would be something that is monotonous. Okay, unless it is some like a usual cos and sine graph, okay, then you know how to sketch it. You have already done that a lot. If it is some other functions, if the first part of the question they already asked us to sketch, it will be something that is monotonous, means it will be strictly increasing or strictly decreasing. So what happens is that if you look at the pattern here, yeah, or the situation here, so we look at it step by step. If, let's say we have got something which is like a tangent theta, so the graph is increasing. So we are looking at a 0 to 1/6 pi, yeah, for the situation here. Tangent theta is increasing. Okay, it's a chord, right? So chord is a 1 over tangent, which will be decreasing. Okay, now because we have got here, it is something related to the chord of a negative theta. So if I've got the chord of the negative theta here, right, something related to that, okay, then it will be something which is strictly increasing for the R here. Okay, so for this, we know that the curve is strictly increasing. So now we prepare, okay, we prepare for the sketch of the graph there. So what happens is that, okay, we could first find out what is the R when the theta equals to 0. So it's very easy to find out. We know this is the starting point, okay, where the R is a 1 over 3. And then because we already know the graph here is strictly increasing, what we need to do is we just need to sketch the graph, which is getting the R, which is like a bigger and bigger, okay? So the R is bigger and bigger here, so you get sort of like an arc here. And because the theta here is only up until 1/6 pi, so we could always draw a line, okay, which is like the theta is equal to 1/6 pi to remind us that, okay, we should stop there. We shouldn't go any further from there already. Okay, so with that, then we will actually have got the graph which looks like this. And then only we show what is like the A there. The A is a 2. So because they tell us that, okay, the greatest distance, okay, from the sea to the pole is 2/3. So where does it happen? So from the sketch, we know that it is strictly increasing. So this would be the point that we have got the furthest from the pole. It happens when the theta is 1/6 pi. So we sub in, okay, the theta is equal to 1/6 pi into the R there, and then we know the R there is a 2/3. So with that, we are actually able to find out what is the value of the A there. Okay, so this question is 3 marks question. So actually nothing much from there. The showing part is 1 mark. So they expect us to sub in the 1/6 pi, and then the sketch here is 2 marks. Okay, so usually the question will allocate the marks like this. Right? So find the exact value of the area bounded by the curve and also the lines. So this is to look at the integration, okay? So we want to find the area, so it's to use the half r squared d theta, okay, for the integral. So of course we square that, okay? We square the r there, so half r squared d theta, tidy up the constants, so we are looking at like a cot square. So for a chord square, we don't know how to integrate it straight away. Okay, so same goes to the case when we have got like a tangent square. We don't know. But we know that in order for us to integrate the tangent square, we can use the identity where the 1 plus tangent square is a sec square. Okay, so 1 plus tangent square is a secant square, so we can integrate the secant. So here is a similar thing, although it's a cotangent, but we can use the identity as well. So 1 plus cotangent square is equals to a cosecant square. Okay, so with that, okay, what we will obtain, okay, here is that cotangent square can be changed to the cosecant square minus 1. Okay, so we're using the fact that when we integrate a cosecant x, we are getting a negative cotangent x from here. Okay, we're getting a negative cotangent x from here. But you have to be careful. Cosecant squared, yes, it gives us a negative cotangent. But why the negative is not there in my answer is because the coefficient of the theta, okay, when we integrate, we need to divide by the coefficient of the theta here, which is a negative. So the negative divided by negative, it will actually be cancelled off. So that's why we don't have the negative there. So it's a positive cotangent. Okay, and integrate the one gives us a theta, so very easy. So after that, right, is a series of like substitution. So we sub all the limits in, okay, the 1/6 pi and also the 0 there. And after that, it's just all about evaluating. So chord, you can think of it as like a 1 over tangent. So you just have to evaluate them. Okay, so all the rest of the evaluation thing here is not very difficult to do already. So once you're able to get the terms here, then it should be okay for us to actually get like the final expression. So usually you can see the question actually asks for the exact value. So usually for the final expressions here is we just leave it in the exact form most of the time. Okay, so that's the part B for the polar, right? Okay, so for the part C here, okay, show that the C has this Cartesian equation. So it looks a little bit complicated here. Okay. Okay, so what we could actually try to work on here is that, okay, because when we try to relate the Cartesian and also the polar equation, right, we only have got like the x is r cos theta and then the y is like a r sin theta. So here it's about a cotangent, okay, so it's not so nice for us to actually work with. So with that, okay, what we could try to do is we just write the cotangent as a cos and over sine, okay, and the angle inside there is something that is not nice. Okay, so we have got like a pi over 3 minus a theta, not just a theta alone. So with that, right, okay, we need to use the compound angle formula. So the first one is like cos A minus B, which is cos A cos B plus a sin A sin B. Denominator is a sine of the A minus B, which is cos sin A cos B minus cos A sin B. Okay, use the compound angle formula to simplify that a little bit. Then evaluate all the cos and the sine of the pi over 3. We have got the 2 there. Okay, so after that we could multiply. Okay, okay, sorry. So we could tidy up and bring this denominator up, and this is what we have. So from here, right, we are already able to see, okay, the things there. So like all the r cos is x, all the r sine is y, and then this r itself is the square root of the x squared plus y squared there. Okay, so with this, then we are actually able to show that this is the equation there. Okay, so a bit of the thing that we need to do here for the 3 marks there. Okay, so the aim here is to change everything to something that has only the r cos and also the r sine theta from there. Okay, so the next question, okay, is vector question. So let T be a positive constant. So L1 passes through the point which is like this position vector parallel to this. L2 passes through this one and also parallel to this. So given that the shortest distance is a 21, we need to find the value of the T. So this is to find the shortest distance between two skew lines. Okay. So basically what we have here is we already have the equation of the line basically. So these are all the provided information for us to form the equation of the line. Okay. But here we are just looking for the distance here. So if we are familiar with the formula, we know that we got to do a few things here. One is we need to cross the directions of the line. We get the result. Another term that we need to do is we need to minus the 2 points that the line passes through. Okay, so use 1 point and minus the other. So it doesn't matter what is the order there. So that is where the vector here will be something which is in terms of the t. Okay, so in the formula that is, we are using the vector which is joining the 2 points. So this is the point minus another point to dot with the cross product of the directions of the line. Okay, put a modulus to it, divide by the magnitude of the cross product of the two directions there. Okay, so remember to put the modulus here, yeah, because sometimes when we do the dot product, right, it will be a negative. Okay, so that's why we will have the modulus in this case here. So when we try to like simplify everything from there, right? So we have got like this is cert21, and then this square root here is also a cert21, so it gives us a nice 21. Okay, so it gives us that the 5t with a modulus is a 21, like that. So the 5t could be plus minus 21. The t here could be plus minus 21 over 5, but we are only taking the positive value of the t, which is a 21 over 5, because it's already mentioned. The t is positive. Okay, nothing much. As long as we are familiar with the formula, okay, for the these skew lines, then we are actually good. Okay. Okay. Sorry, I got the part B. So the plane L1, the plane pi 1 contains L1 and parallel to the L2. So give your answer in a form of like this form, okay, for the equation. So for this equation here, right, that is the form. Okay, what is this form here? A is the point that the plane passes through. B, C are parallel vectors, okay, which are parallel to the plane. In this case, the B and the C here are just the direction of the L1 and L2. Pi 1 is parallel to the L2, so we can take the direction of the L2 as one of the vector, which is parallel to the plane. And since the plane pi 1 contains the L1, we are taking the direction of the L1 as the vector, which is parallel to the plane as well. So the point that it passes through is, we just need to take any point from the L1 because it contains the L1. So the point that the L1 passes through just now is the Ti plus J. So we found out what is the T here. Okay, so we use the value of the T to plug that in. Okay, so that's what the part B. So the plane pi 2 has this Cartesian equation. Find the acute angle between the L2 and also the pi 2. So basically, is to find the angle between a line and a plane. So to find the angle between a line and a plane, we know that we could use the dot product formula, okay? But we can change the cos to the sine straight away in order for us to get the answer straight away. So remember, this only works when we have got a line and a plane, okay? So just take the two vectors from the normal and also the direction of the L2 to do the dot product formula as usual, okay? Just that we can change the formula to the sine from cos. If you want the answer to be the answer here that we get is the answer that we want for this one. Okay, that's for the part C. So part D, find the acute angle between the pi 1 and the pi 2. So basically, we need to find out what is the normal for the pi 1. So the normal of the pi 1 is, okay, because these two vectors are parallel to the plane, we can cross these two vectors in order for us to get the normal. Okay, so we just cross these two, and we will get the normal for the pi 1 then. And in fact, the cross product of the two vectors here, it's already been done here. Okay, we have already sort of done that. So we just take that as a normal and just do the angle between the two vectors as usual. Okay, so that's about the vector question here. Okay, the last question here is about the rational functions. Okay, part A is also something that is very typical, where we have to do the long division, okay, because this is an improper fraction. We need to do the long division so that it gives us a nicer idea, okay, about what are the asymptotes. So we have a vertical asymptote, looking at the denominator x plus 1. So this is the asymptote, which is x equals to -1 for the vertical asymptote. And another one is we have got this term here, which is not part of the reciprocal term. So automatically, that one will actually become our oblique asymptote. So these are the two asymptotes that we obtain. Okay. So for the part B here, find the coordinates of the stationary points on C. So if we have done the partial fraction, it will be super easy for us to differentiate. So we get dy dx, Okay, and when we make the dy dx is equals to 0, it is something very easy for us to solve. Okay, so no matter like what are the methods that you use here, it is actually becoming something quite straightforward already. So that you're actually getting like the x coordinate, and because they want the y coordinate as well, so just sub the x back into the equation to the curve, and we are getting this y. Okay, values here. So these are the points. Okay, so sketch C and stating the coordinates of any intersection with the axis. So we could, okay, find out what are the x and y intercept to help us. So this would be the y-intercept. And for the x-intercept, there is actually no real solution to that. So there will be no real root for the x-intercept there. So no x-intercept. And okay, it's very easy for this case here. It is to consider the asymptote, this asymptote, and this asymptote, okay? And we have got the turning point. So the turning points are here and here, okay? And also, we have got the y-intercept. So by looking at like the clue here, then we know that the graph actually look like this. Okay, so that's how we actually get a graph there. So in the last part there, so sketch the curve with this equation, okay, and find the set of values of x for which the 2 times this modulus of the x squared plus x plus 9 is greater than 13 of the modulus of the x plus 1. So they ask us to sketch this graph first. Okay, so that is we try to look at like reflection. Okay, because this is a modulus graph, so whatever that is below the x-axis has to be reflected up there. So we are going to reflect this part up there. Okay, so this is what we have. Okay, for the graph there, so this we just reflect it up there, and for the modulus, right, and not the modulus, sorry, for the asymptotes, right, if you could reflect it, it will actually help you to draw this part of the curve here. Okay, it will actually help you to draw this part of the curve here. So this is the shape of the curve that we actually have. So the next part, how do we actually solve this inequality here is we just have to rearrange a little bit. Okay, so once we rearrange a little bit, so we can notice that, okay, it's to solve for the second graph, okay, the part where it is greater than 13 over 2. So we just have to look at where is our 13 over 2. Our 13 over 2 is sort of like, it's 13 over 2. 13 over 2 is like a 6.5. Okay, so for the 6.5, it's actually somewhere here only. Okay, so we are actually looking at this intersection only. Okay, and also what happens is that okay, we just have to look at like the this part of the curve, because okay, you see this part of the curve will not touch the 13 over 2 because the minimum point here is a positive 7, so it won't touch the 13 over 2, so there's nothing that we have to look at for that. So there is only this part of the curve which is having the minimum point of the 5 for the y will have intersection with the y is equal to 13 over 2. So basically, we just need to look at the positive part of the modulus there. Okay, so when we solve that, we actually have got the x is half and 5. So when the x is actually like a half and a 5 here, right, we just need to see where is the graph, okay, that is like a like having the graph which is greater than 13 over 2. Okay, so the graph is greater than 13 over 2, which is this part, okay, and anything which is less than 1 over 2. So in this case, we will have the solution for the x here, which is x is greater than 5 and x is less than 1 over 2. Okay, so here's the thing. The answer will accept this in the mark scheme. Okay, they can actually condone the fact that the x equals to -1 is an asymptote. So it shouldn't be included in this inequality here, because this inequality contains x is equals to -1. Okay, but the mark scheme actually condone that, they allow us to write that. Okay, but in a more formal way, right, we should try to avoid the x is equals to -1 in the sense that for this part here, it will be more formal or better if we write it in this way. so that we exclude the x is equals to -1 because again x equals to -1 is actually the asymptote. We shouldn't have any x value there. Okay, it's better if you write it in red like this, but like I said, in the masking allows us to use the first one. Okay, so the question about the graph sketching here, right, is we really have to look at the thing that we sketch here, and the last part of the question is usually to look at the intersections and we check the graph and to solve for the inequality there. Okay.